Hello everyone, hope you all are well. So now in this video we will discuss physical properties of haloalkanes and haloarenes. Let's begin. First is nature. The nature of haloalkanes and haloarenes, normally all the halides are colorless. Just bromine and iodide on heating gives color, show color. Similarly, if we talk about lower homologs like methyl, ethyl, these are gases. But when we talk about carbon atom from 3 to 6 or 7, then it will become liquids. And from 7 carbon onwards, all are solids. This is the nature of haloalkanes. Next is solubility. As we know from the nature of this RX bond, this R is basically carbon with which this halogen is attached. It has 3 more bonds. This halogen is partial negative because it is highly electronegative. So due to this carbon will acquire partial positive charge. This indicates that this bond is polar. If alkyl halides are polar, then it will more better dissolve in polar solvents because like dissolves in like. Polar will dissolve in polar solvents. But the question arises, if the alkyl halides are polar, it will dissolve in polar solvents. So as the water is polar solvent, then why it is not soluble in water? The reason for this is water exists in this form along with other water molecules in a solution. It forms a hydrogen bond with large number of water molecules. It exists in this form. But when this alkyl halide have to be soluble in water, dissolved in water, then the energy released as this molecule has van der Waals forces, which is a weak force, so it will break easily with the less energy, and that energy will not be sufficient to break these strong hydrogen bonds. If these bonds will not break, then water molecule will exist in associated form. So, if the water molecule is in associated form, this alkyl halide will not dissolve in it, will not become soluble in it. So, due to this reason, alkyl halides are insoluble in water, but it dissolves in polar solvents. Next is density. If we compare the mass of ethane, if we compare the mass of methane, CH3H and methyl halide, here the mass of this halogen is varied along with this hydrogen. Mass of halogen is more than hydrogen. So we consider the mass of alkyl halide will be more. If the mass of alkyl halide will be more, density is directly related to mass upon volume. If mass is more, then density will also be more. So its density is always more than its homolog hydrocarbon. Next is dipole moment. Dipole moment, as we move down the group, fluorine, chlorine, bromine, iodine, as we move down the group, electronegativity will decrease. As the electronegativity decrease, down the group electronegativity decrease. If the electronegativity will decrease, then its dipole moment will also decrease. But there is the exception. The dipole moment of chlorine is more than fluorine. Why? The reason for this is the size of fluorine is less. Due to the small size, its bond distance is also less. As we know, mu is equals to Q multiplied D. If this bond distance is less, then mu is also less. So, as compared to mu Cl, mu F is less. Dipole moment for fluorine is less. Now the last point, melting and boiling point. Now if we talk about melting and boiling point, there are certain factors. Number 1, if we compare it with its corresponding hydrocarbon, its melting point or boiling point will be more, because it has more van der Waals force of attraction, so its melting and boiling point will be more. Second, more the number of carbon atoms, more longest the carbon chain, more will be the melting and boiling point. More the number of halogen atoms, more will be the melting and boiling point. And last, branching. As both have 4 carbons, but the melting and boiling point of this and butane is more, because more the less the branching, more will be the surface area, more will be the melting and boiling point. Now if we compare the aromatic case, ortho, meta or para isomer, para isomer has more melting point as compared to ortho and meta, because when we packed it in a crystal lattice form, as para is just like this, when we pack it, it will be closely packed, but this will not happen in ortho and meta case. So we will consider para has more melting point than meta than ortho. If we talk about boiling point is all comparable, same, almost same. Now let us discuss one question regarding this. Out of these, which has the more melting and boiling point? If we talk about these two structures, out of these two, which factor dominates? More the number of halogen atoms, more will be the van der Waals force of attraction, so more will be the melting and boiling point. So B has more melting point than A. Now, in case of this and this, here is 1 halogen and here is 2 halogen. So this C has lesser melting and boiling point. So now just like this, you can get a number of questions related to it. Arrange them in the increasing order, in decreasing order, on the basis of these all concepts. That's all in the physical properties. Thank you and have a nice day. For more such videos, kindly like, share and subscribe this channel.